Word. All right, this is 2010B number 6. This is this test's position velocity acceleration question. You're told that you have a time interval from 0 to 6, and you're given position functions for particles P and R. So those guys right there are position functions. In part A, it says between 0 and 6, find all times where R is moving to the right. Okay, well, if this is R's position function, then his velocity function would be his derivative. So R prime of t is equal to 3t squared minus 12t plus 9. Factor, okay? You're going to make a number line analysis, and you have your end caps, okay? You have a closed interval, got to have those end caps. R prime of t is equal to 0 at 1 and 3, okay? Plug and chug, you guys know how to do that, okay? And then so he's moving to the right where that's positive, and it's positive between 0 and 1 and between 3 and 6. Part B. Between 0 and 6, find all times t when the two particles travel in opposite directions. Well, I know what direction R is traveling in at all those times, but I don't know what direction P is. So I need to do the same thing to P, do a number line analysis of his derivative, and then compare them. So that's the position function for P. So if you derive it, you'll get the velocity function, right? The 2's along for the ride, times cosine derives to negative sine of whatever, times the derivative of the whatever. Okay, clean it up a little bit, puts me to here, all right? And then when is sine 0? Sine 0 at 0 and pi and 2 pi, etc. So if I plug a 0 in, that's already an endpoint. To make this say pi, that has to be a 4, okay? And then to make that say 2 pi, well, that'd have to be an 8. And that's outside of my interval, so the only t value that makes that say 0 is 4. All right, so here's my number line. Pick something in between 0 and 4. 2 seems like a really easy value. You know the sine of pi over 2 is 1, times something negative gives you negative. And then something between 4 and 6, maybe 5. So the sine of 5 pi over 4, 5 pi over 4 is in quadrant 3. Sine's negative there. So you've got a negative times a negative giving you a positive. So there we are. Now, when do this guy and this guy have opposite signs? Well, between 0 and 1, this guy's positive and this one's negative. So we're traveling in opposite directions there. And then also between 3 and 4, this guy's negative. And between 3 and 4, this guy's positive. So we're traveling in opposite directions then. Part C, find the acceleration of P at time 3, and then decide if P is slowing up, or is slowing down, speeding up, or doing neither at time 3. Okay, so the acceleration would be the second derivative of position, right? So position derives to velocity, derives to acceleration. So again, that negative pi over 2 is just along for the ride. Sine derives to cosine of whatever times the derivative of the inside. Pi times pi is pi squared. Don't be afraid of it. It's not a big deal. Okay, so that puts me to here. Now you're going to plug a 3 in where you see t. So I'm now at the cosine of 3 pi over 4. You know that's negative root 2 over 2. Okay, and then put those guys together, gives you pi squared root 2 over 16. It's kind of an ugly answer, but it's right and it's fine. Don't freak out about it. Okay, and so now we're just comparing signs, right? So the velocity at time 3 was negative. The acceleration at time 3 is positive. So this thing's slowing down. And then part D, write but do not evaluate an expression for the average distance between the two particles on the interval between 1 and 3. The distance between the two particles, well, that's like the distance between their outputs. So the distance between them is r of t minus p of t. Now, let's just say that that was negative at some points. You don't want that to be negative because distance is always positive. So by putting the absolute value bars on there, like, you're good. It'll just be the distance. Okay, it asks for average distance, so that's like the average value of the distance. I say average value, you say. All right, and so here's 1 over b minus a, integrate from a to b of your distance function, and that's it. You don't have to evaluate it.